Okay. This video is in response to Veritasium's video. I'll put a link right here so you can go watch it first. So the first physics phenomenon is the Kane balancing thing. Basically, so we have this sword, this nice handmade sword. It's pretty long, so I'm going to hold this out for you, Brent. You put your fingers where you think the center of mass is. Oh, pretty close. So that's hard, but if you start out wide and then go in...
Friction.
You end up at the center of mass. So, you mentioned friction.
Yeah, at the very beginning I couldn't move my right finger smoothly across, or like at all.
Yeah. Well, if you did, what would happen?
Well, it would fall.
Yeah. Right. So, I think that one's pretty simple, that basically either you manage to make it to the center of mass or you're going to drop it. Like, those are the only options.
I was thinking that I could do like coefficient of friction stuff and see it's like if mathematically it has to happen.
You could do the math. Cool. The second one is the phone flip. Let me move this out of the way. This is easy, and that's, well, yeah, basically, but you can't really make it flip straight on this axis, the long axis. Yeah.
It's not one of the axes of rotation. Principal axes, I mean. We learned about those in Lagrangian mechanics.
You think it's because the center of mass, like that, it maybe is centered this way and this way? Or, but not the other way, and that's why it doesn't work?
Yeah, that could be.
Other than that, I can't really think of why that would happen. Except for if there's maybe some principle that this axis of rotation doesn't work. I don't know. Okay, that's our best guess. The water in the cup. We used to do this with combs or a hairbrush. Like you brush your hair and then you put it next to the stream of water and it curves.
Yeah. That one, like, okay, there's moving water and there's an electric field, and the first thing I thought of was relativity and special relativity, and it would appear to be a magnetic field, but it's not got, the water isn't going nearly fast enough for that to matter at all. So, I'm trying to think of something else that would have done that.
Yeah, and it's not. The molecules could change their orientation, but not their direction.
Well, what do you mean?
Well, like, the water molecule could, you know, turn so that the positive faces negative, but not make it change its... I don't know. Well, what if the water molecules are attracted to themselves?
I mean,
or to each other? Would that make them curve?
It just would make them aligned, I guess. Like a liquid crystal, but not actually like a liquid crystal.
Okay, we're stumped. Number 4, the magnetic cereal. This one's easy because there's iron in cereal. In fact, they put iron and a bunch of other vitamins and minerals into cereal, like Cheerios, so that you get better nutrition out of it. I even remember seeing on Bill Nye the Science Guy, I think, he put a bunch of cereal and some water into, he chopped it up in a blender, and then there was a magnet at the bottom somehow, and basically chopped it up and it went through for a while and poured out the gunk, and then at the bottom attached to the magnet was like this chunk of little tiny bit of iron. So that's why you need a really strong magnet, because it's a little bit of iron, but it's in there.
Just use an MRI.
That would work. And finally, teabag rocket. So basically it was like the last little embers went up. What is fire?
Oxidation.
Why does fire go up?
Because it's escaping gravity. Not right. Because it's lighter than air and it's escaping gravity. Because density things.
So would that apply to an ember?
If it's light enough.
It didn't work until the very end, you know. I mean, you see that around a campfire too.
Yeah.
So if that is the case, explain it more thoroughly.
Well, I actually don't know if that is what causes it to rise. But if it is, it would be the tiny little bit that's left would be light enough that the updraft created by the fire would be able to pull it up.
So fire creates updraft?
Mm-hmm.
How?
Okay.
Why? When?
By the temperature... Gay-Lussac's law? Yeah. Combined gas law. If it heats up, it gets less dense. And so less dense things will rise. And so the air heated by a fire will make a rising column. Okay.
Cool. Okay, those are our educated guesses. We'll tune in a week to see if we're right.